Hi, this is Mr. Forster here, and this is Mole Vodcast number 2. And in Vodcast number 2, we're talking about stoichiometry, which is another kind of fancy term for how the moles relate to mass, all right, in a chemical equation. All right, so remember our chemical equation, we got something plus something gives us something plus something usually. All right, so we're going to look at how moles relate to that. The first thing you do is kind of see how moles relate to the whole overall process. So we know a mole allows us to do chemical conversions. Okay, remember we had our chart. We had atoms, we had moles, and we had grams, and we could interconvert between the two by multiplying and dividing. But we can also use this knowledge of mole conversions in a balanced chemical equation to find amounts of substances. All right, so that's what stoichiometry does. It uses the mole concept to find out some different amounts of a few substances in a chemical equation. So there are some steps to doing any stoichiometry problem. Step one is you must first always have a balanced equation. All right, so the equation must be balanced. All right. Secondly, they're going to give you some information usually in the problem. All right, so after you've written the equation out, you always want to write what you know under the equation. All right, we'll look at an example here, and then thirdly, decide what type of conversion you need to do. Okay, sometimes you may have to do a mole to mole conversion, which we'll talk about. Sometimes you'll have to do a mole to another type of mole back to a gram amount, so you'll have to convert from grams to moles, or vice versa. Sometimes you will be given a gram amount, you'll have to convert that to moles, and then convert that to another form of moles, and then convert that to grams. All right, so for instance, this is moles of A, and I want to convert it to moles of B. All right, so I can look at the grams of A and convert that to moles of A. Then I can convert the moles of A to moles of B, and then finally back to grams of B. All right, so let's kind of look at a problem here. There's 3 more steps we need to talk about first. Once you get all those amounts, all right, usually you'll be given some gram amounts. You always want to convert those to moles. And remember, we'll kind of talk about how to do that. Step 5 is convert the chemical you start with to the chemical you want to end up with. Okay, so the chemical you start to the chemical you want. So from there, you can then convert, usually back to mole or to grams from the moles. So I'm doing from a conversion from moles to grams. All right, so here's an example here. So I have a reaction. I have K2SO4 plus lead nitrate, which is PbNO32, and I want to convert, and that's going to give me 2 products, KNO3 and lead sulfate. Okay, so the first thing I'm going to do is write what they give me below. So it says I start with 25 grams of potassium sulfate. All right, from there I'm going to always have to usually calculate the molar masses for each. So I want to write those below those numbers. So this one is 174. I've already calculated these for us here. 174.26. This is 331.2. This one is 101.1. And this one is 43.3. Oh, no, that's wrong. That is actually 303.26. All right, I was reading off the wrong line. Okay, so in this first stoichiometry problem, we always start with what we're given. Okay, so we're given 25 grams, and I want to convert that to moles. All right, so to do a gram to mole conversion, we have to divide by the molar mass. So I'll take 25, and I'll do this in the show work column here. So 25.0 grams divided by 174.26. That will give me, and that'll give me a mole amount. I'll write that down here, 0.143. All right, now we have to ask the question, is this equation balanced? Okay, we need to do that first. I should have done that first. Okay, and to balance that equation, I need to put a 2 there. Okay, these all other ones will be 1s. 1, 1, 1. All right, so a trick here is that to get these other mole amounts, I don't have to really look at any gram amount. I can just go off the mole amount for the one thing that I do know. All right, and wherever the coefficient, remember the coefficient is the number in front of the element, wherever that's the same, my mole amount's going to be the same. So for instance, this K2SO4 is 0.1143. This lead nitrate will be 0.143. Right? And also the same thing over here with lead sulfate, 0.143. However, since it's going from a 1 and the KNO3 has a 2 in front of it, I need to double, basically. So I'm going to multiply that 1.143 by 2. That'll give you 0.28. All right, so when I actually 0.286. All right, so once I'm there, once I have all the mole amounts, I just have to convert those back to grams. So to convert back to grams, I'm going to have to multiply. So I'll take 0.143 multiplied by 331.2, and that'll give me 47.4 grams. And then I'll do the same thing here, 0.286 multiplied by 101.1. That'll give me 28.91. And then lastly, I will convert this one back to grams, 0.143 multiplied by 303.26. That'll give me 43.36. Okay, so that is a basic stoichiometry problem using the mass of a reactant that's given, or a certain chemical that's given, and using that to get moles, and then going from moles to working back up to get the grams for the other things. Now, a way to make sure that I have done this right, or that I've done all these calculations right, I can add up these two amounts here on this side and these two amounts on this side, and back. And if I add them up and it's the same, or pretty much the same, then I know I did it right, because what I start with has to be the same mass as what I end with. Okay, so if I do that for this side, I get 72.4, and if I do that for the product side, I get 72.27. So pretty close. All right, so remember, this is a function of a law we've talked about previously. Okay, in the response section, I want you to enter that law. Okay, it's a law of something. All right, so enter that law in the response to this lecture section.